Year 12s! In today's video, we are going to look at Bernoulli sequence, the binomial probability distribution, and the expectation and variance of the binomial distribution. Let's look at Bernoulli sequences first. The Bernoulli sequence is used to describe a sequence of trials that result in one of two outcomes, either a success or a failure. In addition, the probability of success in a single trial, p, must be constant. Hence, the probability of failure is 1 minus p. Note that the probability of success and failure must add up to 1. This is why, if the probability of success is p, the probability of failure must be 1 minus p. Lastly, a Bernoulli sequence is independent, and the outcome of the trial is not affected by the outcome of any previous trial. Now, let's look at binomial probability distribution. The number of successes in a Bernoulli sequence of n trials is called a binomial random variable, and in general, we can find the probability of achieving x successes in n independent trials of a binomial experiment by using this formula. Here is an example for binomial probability. The probability that a soccer player has ever scored a goal before is 0.72. Find the probability that of 5 soccer players chosen at random, at least 3 have scored a goal before. Now, if x is the number of soccer players who have scored goals before, then using the formula, the probability of x equals x is 5 choose x times 0.72 to the power of x times 0.28 to the power of 5 minus x, where x is 0, 1, 2, 3, 4, or 5. Since the probability that each individual has scored a goal before is 0.72, according to the Bernoulli sequences, the probability that they have not scored a goal before is 0.28. Since the question asks for at least 3 who have scored a goal before, this includes 3, 4, or 5 soccer players who have scored a goal before. So we're trying to find the probability of x being greater than or equal to 3, which is probability of x equals 3 plus probability of x equals 4 plus probability of x equals 5, which, when we plug them into the formula, gives us the following. The 5 choose 3 notation can also be expressed using factorials. So we can expand these equations from the binomial form, seen here, using factorials. As you can see, 5 choose 3 has become 5 factorial over 3 factorial multiplied by 5 minus 3 factorial, and so on. Now, overall, this equals 0.8624. So therefore, the probability that out of 5 soccer players, at least 3 have scored a goal before, is 0.8624. Finally, the last thing that we'll be looking at is the expectation and variance of a binomial distribution. This is very similar to what we have learnt in the previous discrete random variable video. In order to find the expected value for a binomial random variable, we have to multiply the number of trials by the probability of success. This is given by the expected value equals np, and the formula for variance is np times 1 minus p, the number of trials multiplied by probability of success and probability of failure. Let's look at this in the following example. The probability of raining this winter on any particular day is known to be 0.2. Of 100 days, how many days would we expect it to be raining? Find the standard deviation of the number of days it would be raining in this winter. The number of rainy days is a binomial random variable, with the parameters p equals 0.2 and n equals 100. We can expect that the expected value is np, so 0.2 times 100 days, which means 20 days will be rainy. The variance is np times 1 minus p, which is 100 times 0.2 times 0.8, which gives us 16. Hence, the standard deviation, which is the root of the variance, is root 16, which is 4. Thank you for watching the video. Happy studying! Click here to go to the Engage Wiki. Click here to go to the next video. Or, if you really want, you could just stare at this motivational poster.